we will finish the chapter today. The chapter 4 is going to be finished. I warned you about this back when we started chapter 3, that we are going to put chapters 4 and 3 together, make one unit, and you'll be tested on 4 and 3 altogether. So next time we're together, we'll just have a massive review session and hopefully get you through this test successfully. Okay? All right, so we want to go over some of this. Actually is going to be ancient history, because the basic counting rule we already talked about when we did mutually exclusive or independent events. If you want the probability of 2 or more things happening in a row, you can simply multiply the probabilities. Well, that's basically what we're doing here. The basic counting rule, if there are actions to be taken in a certain order, and here are your number of choices per each action, you simply multiply, okay, the total to get the total number of possibilities. So at my sub shop, there are 3 choices for rolls, 4 choices for meats. How many different sandwiches? 3 ways to pick your bread, 4 to pick your meat. 3 times 4 is 12. Basic counting rule. And I got a pop-up. Oh, yes. Okay. So, how many phone numbers before a new area code would be necessary? You have 10 ways you can pick this number. 10, 10, 10, 10, 10, 10. 10 to the 7th, which is 10 million phone numbers before you need a new area code. Okay? 5 books are to be placed on a shelf. Total number of arrangements. The order is very important. Is this not a 5p5? Yeah, permutations. Suppose you only had room for 3 of the books. Would it not be a 5p3? Order is still very important. Okay? Let's verify by placing 2 books out of 4. A 4p2 should be 12, I think. Let me double check that. A 4p2 is, try that again, a 4p2 is 12. All right, so if I have 4 books, okay, can I get 12 arrangements? So I have a B, I have a C, I have a D, BC, BD, CD. 6, and you can turn each one of those around. Do them in the other order, total 12. Okay. See, this is why I hit you folks with combinations and permutations a while ago, because I knew this was coming. At the racetrack, an exacta wager picks 2 horses to finish first and second. Is the order important? You bet it is, first and second. How many different wagers would there be out of 12 horses? 12p2, right? Now, committees. How many ways can committees? The order is not important, right? Me, Sally, and Joanne is the same as Joanne, Sally, and me. Committee. Can we pick 3 out of 5? 5C3, which I think is 10, if I'm not mistaken. Yeah. There are 10 boys and 12 girls in a class. How many committees of 8 can be formed, right? Out of 22 people, right? Out of 22 people, 22 C8. That's how many ways you can pick 8 out of 22. Okay? Find the probability. Find a probability of getting exactly 2. So here's our total sample space, all the committees. If you want to have exactly 2 girls, how many ways can you pick 2 girls? And the order is not important. It's a committee, darn it. 12C2 is the number of ways you can pick the girls. To get 2 girls, we still need committees of 8. We still need 6 people. And if there's only 2 girls, we got to get the 6 out of the boys times 10C6. Okay? And that will give you the probability of having exactly 2 girls. Okay? Exactly. Find a probability of at least 5 boys. If it is at least 5 boys, we're having 8 on the committee. We could have 5 boys, 6 boys, 7 boys, 8 boys, right? So we could have 5 boys, 6, 7, or 8. So what was our total sample space? 22C8. How many ways can I get 5 boys? 10C5. But if I have 5 boys, I'm going to need 3 girls, right? So 10C5 times the girls, 12C3. Now, if you want 6 boys, you got to pick 10 out of 6. And we would need 2 girls times 12C2. 7 boys. How many ways can I get them out of 10? 10C7. I only need 1 girl, which would be a 12C1. And finally, if they're all 8 boys, how many ways can I get 8 boys? 10C8 and 12C0. No girls. Okay? That would have at least 5. 5, 6, 7, or 8. Okay? Suppose license plate of 3 letters and 4 numbers was changed to 3 letters and 4 numbers 0 through 9. How many are possible? Okay, you have a license plate with 3 letters, 4 numbers 0 through 9. How many are possible? Well, there's 26 ways you can get the letters. Now, the numbers 0 through 9 are 10 numbers, so times 10. Okay? Just to figure that out, pretty big answer. Should be 17,576 different license plates. That's totally not totally true, because you can't use just any arrangements of letters, because some arrangements of letters spell out interesting words and they try to avoid those on license plates. So it is a little fewer than that, but it's kind of a fun problem. Whoops. At McHart's, the big sandwich has a choice of ketchup, onions, mustard, cheese, and tomato toppings. How many different sandwiches are possible? How many different sandwiches? You could have sandwiches with no toppings, with 1. How many toppings are there here? 1, 2, 5 toppings. You could have 1 topping, 2 toppings, the whole way up to 5. So how many ways can you pick a sandwich with no toppings? Isn't it 5C0, which is just 1 way to pick a sandwich with no toppings? You don't pick any, right? Okay, if I'm picking 1 topping, 2 toppings, 3 toppings, 4 toppings, and 5 toppings. So there's I know there's 1 way to pick none. There's only 1 way to pick with 5. You pick them all. How many ways are there to get sandwiches if you pick 1 topping? Isn't there 5? And thus there would have to be 5 with 4, because those are the 4 left over after you pick 1. A 5C2, I think we said, was 10. And a 5C3 is 10 also. 32 different ways. You ready for something really beautiful? Ready? Goosebump moment? Think about 5 toppings. Do you want the first topping, yes or no? That's 2 possibilities. Do you want the second topping? Yes or no? That's 2 possibilities. Do you want the third? Do you want the fourth? That's 2 times 2 times 2 times 2 times 2. 32. Ah. Okay. 5 people meet at a party. How many different handshakes are there? Easy way to do it. How many ways can you pick 2 people out of 5? The order is not important. When I shake Sarah's hand, she's shaking mine. So the order is not important. 5C2 or 10 different handshakes. Another way you could do it, each person can shake how many hands? I could shake 4 people's hands. Everybody in the 5 could shake 4. 5 times 4 is 20. But when I shake Tom's hand, it's the same as him shaking mine. So we've got twice as many. 20 divided by 2, it's still 10. Okay? Great stuff. All right. Key ring has 4 identical keys on it. What's the probability of opening your apartment door in the first try? First try, 1 out of 4 chance. Easy, right? What about opening your door on the second try? That means you don't get it on the first. What are your chances of not getting it open on the first try? Isn't it 3/4, right? And it says, if you remember which key you've tried, now we have 3 left. If you want to get it done on the second, you have 1 chance out of 3, correct? Cancel the 3s, second try, 1 out of 4. Isn't that weird? What about on the third try? All right, you have 3 out of 4 ways of missing it on the first. There's 3 keys left. What are your probability of missing it on the second? 2 out of 3. There's 2 keys left, and you want to get it on the third. You want to get it 1 out of 2. Cancel, cancel. 1 out of 4. Every time it's 1 out of 4. That is such a weird problem. Baseball coach has 11 players who can play the outfield, any one of the positions. So the arrangement, left, right, center field, very important. 11 P3, right? Okay. A few years ago at SU, they wanted to see how students in analytical thought courses were doing. And so in general, they told professors to include a problem on the test, the final exam, and there would be a committee that looked over all the examples of that one problem from everybody who took the test. They picked a great problem, and guess what it was? Just like this. Okay? Great problem. You got to be able to do these problems. At a TV factory, TVs are inspected in groups of 100. We're selecting 5 out of the 100. 6% of the TVs are bad. Okay? So that means you have 6 bad TVs and you have 94 good ones. Yeah? Okay? We are selecting 5 out of the 100 to examine. How many different ways can I pick 5 TVs out of 100? Is the order important? No. 100 C5 is the way I can get 5 TVs out of 100. Now, what's the probability 2 of the 5 are bad? What's the probability exactly 2 are bad? Well, how many ways can I pick 2 bad ones out of 6? Right? 6C2. If I have 2 bad ones and I need 5, the remaining 3 have to be good ones. How many ways can I pick 3 good ones out of 94? Do the math, divide, and it's not a bad problem. Okay? 44 women, 30 men in an auditorium. Okay? If 5 men are selected, if 5 people, sorry. So how many ways can I pick 5 people out of 74? Isn't it a 74 C5? I want to pick 5 people. What's the probability of getting 5 guys? How many ways can you pick 5 guys? 30, C5, right? And out of the women, I'm not picking any. Yeah? Do the math and divide. All right, one final problem here. Very much like the TV problems. You pick 6 numbers from the numbers 1 to 33. At the end of each day, 6 winning numbers are selected randomly. So there are 6 winners. So I have 6 winners. And don't I have 27 losers? Yeah? Are you with me? Okay. To win a prize, you need to have selected at least 3 winners. 3, 4, 5, or 6. 3 winners, 4, 5, or 6. Correct? Okay, total sample space. Total sample space, how many ways can I pick 6 numbers out of 33? There it is, total sample space. Now, to get a prize, you've got to have at least 3. So we'll start with 3 winners. 3 winners. How many ways can you get? 3 out of 6. 6, C3. But if you have 3 winners, don't you have 3 losers? Times 27, C3. There's getting the 3 winners. Now I want 4 winners. How many ways can I pick 4 winners out of 6? And now, because I have 4 winners, I only need 2 losers. Yeah? Okay? What if I want 5 winners? I want to pick out of 6. I want to get 5 winners, and I only need 1 loser, right? And finally, if you get all 6 winners and win the jackpot, 6C6 and no losers at all, okay? And that wraps up the unit, including chapter 3 and chapter 4. Next time, big review session.